Okay, so guys, we're looking and going to be working on projectile motion problems today. So to do so, you have projectile motion problems are broken down into two portions. All right, usually they have a y component and an x component. Each kind of component has their own set of equations. You have your x components, all right, over here, the horizontal motion equations. Okay, you type everything here into the triangle, what each value stands for. Vx is horizontal velocity or speed. You need to know that that remains constant through the entire motion of the object. Dx is your horizontal displacement or distance. Okay, this little star, double star. If you're reading a problem that doesn't give you the full information, that's basically saying how far away is the object, how far from the base, what is the total distance traveled. That will be your dx. T is time. Now, how we use the triangle again, cover up the variable you're looking for. If I'm looking for t covering that up, what does t equal? dx over vx. Okay, if you're looking for vx, it's dx divided by t. If you're looking for dx, it's vx times time. Now, there are going to be certain problems where they give you a piece of information from both the horizontal components and something from the vertical end. So basically, the only variable that is shown in both of these sets of equation is what? Time. X and X, horizontal. All right, Y's, those are your verticals. So if you're given both dx and vx, you can use this equation to solve for time. And then time can help us find its vertical speed at a certain time, how far it is fallen. Okay, now if you're not given one of these two, if you're not given a vx or a dx, but they ask you to solve for one of them and you don't have time, that means that you're usually going to be given height. So if you're given a height of something, 2 times dy over 10 square rooted, you can use that to solve for time. So time is going to allow us one of those two equations. This dude or this dude is going to allow us to kind of hop back and forth. We took a look at yesterday what all these variables meant. Remember that gravity, guys, we're using -10 meters per second squared, even though the actual number is -9.8 meters per second squared. So the first one, very, very simplistical. Stone is thrown horizontally from the top of a 572 meter high dy cliff. How long does it take the stone to reach the bottom? All right, so t is what we're looking for. Now there's two equations that we can use. T is equal to dx over vx, or t is equal to 2 dy over 10 square root. Well, seeing how we're given dy, the equation that we're going to use is 2 dy over 10 square root. You're given dy, so it's going to be 2 times all right, and then we're just going to need to punch that into a calculator. Make sure you do everything that's under the square root first. So 2 times 572, good, divided by 10, good. Square root, yeah, that answer. You're going to get a kicked out answer of 10.695. We'll just round it to 2 decimals usually. In this case, we can't, or we could, it would be like 10.70. And the unit, what would the unit be here? Well, if we're looking for time, all right, our unit is going to be in seconds. And then we're just going to box this answer off. The next one. How far does a ball land from a cliff? dx. That's what we're looking for. If it has a horizontal speed, which is vx, of 26 meters per second, and is in the air for 7.7 seconds. So dx is our question mark. That's how we would always write these things out. If you know what you're looking for, write it out, question mark, and then find it on your equation sheet, and then rewrite it down in the problem. So I'm looking for dx. Cover that up. and that is going to equal Vx times time. And so plug in our values. All right, since we have them, this is super, super easy. It's kind of just a plug and chug. Okay, Vx is 26, and T was 7.7. So this one's just simple multiplication. 200.2. And the unit, well, what are we asked for? How far from the base of the cliff? That's dx. So dx is the distance or displacement. We're going to use meters here. We're going to box that answer. Now the next one. So a steel projectile is shot horizontally 24 meters per second from the top of a 1,258 meter high tower. How far from the base of the tower does the projectile hit the ground? And I put need time first as our little hint here. So we're asked for dx. So because we already should have the equation like we had for the previous problem, it would be Vx times time. We do have Vx. That's 24. But what don't we have? We don't have time. So we need to do something for time. Now, we can't use this equation because we're actually looking for dx. You can't have two missing variables in a 3-variable equation. So, okay, if you're not given time and if you're given height, you're going to use this equation to solve for t first. So it's a 2-step problem. So t is going to equal 2 dy over 10 square root. And then let's plug in our numbers for that. It's going to be 2 times 1258 over 10 square root. Punch it in. And you're going to get 15.8619. Let's round it to 2 decimals. So we'll have 15.86 seconds for the time. Okay, but that's not what our full answer or full question was. It wanted the distance horizontally that this thing is going to travel. So since we now have Vx and T, now we can plop it into our equation. So 24 times 15.86. That is going to crank out an answer here for us of 380.64 meters. Box off that little answer. Shabam. Now, the last one on this first page. A person standing on a cliff throws a stone with a horizontal speed of 15 meters per second. It hits the ground 47 meters from the base of the cliff. How high is the cliff? Okay, so some problems, guys, don't have all of these, all right, listed for you. I did this because it's the first time we see it. So if you can get used to, all right, reading a problem without having that there, that's huge. Because once you know what your variables are, this becomes so much easier. So they want to know how high our cliff is. Now I took off the original portion of our equation from yesterday where it was VI times T plus 1/2 GT squared, because these are the horizontal problems. We're not launching anything up, so it has no initial velocity in the positive or negative direction. So that's why I'm just leaving it out, because it would be 0. So that we want to know how high it is, we need that. So dy is equal to 1/2 GT squared. So what we really need is T, because we already know gravity is constant. Ours is a -10 that we're using. So T. Can we use this equation? Yeah, nah, because we don't have the height. We don't have dy. So we go to our other triangle. All right, we go to the horizontal set. T would equal dx over vx. So let's see, do we have both of them? All right, vx, yes, and dx, hell yeah. So T is dx over vx. We have both of them, so we can punch those in. 47 divided by, was it 15? And that is going to equal, it's like 3.13 repeating. So we'll just chop it off. We'll call it 3.13 seconds. Now this dude is going to get put there for T. So it's going to be 1/2 gravity. We're using -10 times our time squared. And when you're doing this, guys, please only square the T in the equation. So we're at 3.13 squared times -10 divided by 2. Get us cut in half. Now that kicks out an answer of -48.9845. We'll call it chopped rounded to 2 decimals, so it'll be -48.98. But this may not be an acceptable answer because what that is a displacement. This is telling us that the object is 48.98 meters below where it was. If they're asking you for height, well, the height would just be the same answer, just not negative. Okay, so this is our displacement, which is telling us that it's this far below where it was. That means that, okay, well, that thing has to be that high up. Okay, so if we go to the next set of problems. We have an object that has a speed of 24 meters per second that landed 95 meters away from the base of the cliff. Find how high the cliff is. So we're looking for dy. All right, this problem is just like the last one we had just done. So once you know what you're looking for, figure out what the equation is. 1/2 gt squared. We need t because g is a constant value. So we can't use the t is equal to. We can't use this equation because we don't have dy is what we're looking for. So we got to go to this dude. So t is going to equal dx over vx. You have both of those values. Make sure you put them in the right position. If not, then you can definitely screw yourself up. So we should have 95 over 24, and we should get an answer of about 3.96 when we round seconds. Okay, once you have that, then you substitute it into the equation for the t that we needed. So we're doing 1/2 g, which is -10 times our t squared. Again, only square the time. When you do this out, you should get an answer of -78.41 meters. But again, they ask, find how high the cliff is. So you can't have a negative height. So we're just going to rewrite this as a positive value. Box your answer. even though it's really awfully drawn box. That. All right, so let's do one more, and then you guys can be able to. You should be able to work out the next couple of problems pretty easily. So we have a bridge that is 176.4 meters above a river. If a lead-weighted fish line is thrown from the bridge with a horizontal speed of 16 meters per second, what horizontal distance will it travel before striking the water? So I kind of put the hint here, use the t equation with a dy in it first. So looking at our equation sheet, they want dx. So dx, we cover dx up in the equation. Dx is equal to dx times time. We need these two values. Now you have dx, which is given as 16. T, we don't know. All right, so that's why I wrote it up here. And we cannot use this t equation because we're looking for dx. So again, can't use that. And so we're looking, if we're given the height, you can use this here equation to solve for t, which you need to do first. Okay, so we're doing 2 times the height, which was 176.4. Divide that by 10, and then take a square root of that. And we're going to get an answer there of, once we round, 5.94 seconds. This guy gets substituted into this equation. So now we have t, right? That 5.94. All right, and then we're just going to plug it in. 16 times 5.94. And that's, all right, that is that. So the last 2 problems are going to be for you guys to do on your own. All right, you should be able to complete this now that we've done a few of these practice problems together. You have your equations, and you have anything else, you need. All right, hopefully this